Descartes proved that you should believe in God using this. He assigned some probabilities and proved that it's worth your while to believe in God using this very argument. So I was going to make a quiz out of it last term, and I decided I didn't want to cross any religious boundaries. So, very interesting though. It's amazing how far-reaching this can go. All right. You hold some stuff in your hands, dice and coins. Let's keep the dice theme going, yes? Let's keep the dice theme going. Experiment number 2. Although we're not actually going to roll them. I'm going to let Excel do the rolling for us. Roll 2 dice. Okay. What I want to do, why would I care about rolling 2 dice? Okay. Say that again? Well, did I take it from you? Oh, it's on the floor somewhere? Here you go, Lydia. Here's a green one so you can mix and match it. Beautiful. Merry Christmas. I had a thought it's gone. Oh, why would I care about 2 dice? Zach says there's twice the... Good, I love that. It makes things more interesting because it becomes exponential. Why else would you care? What games use 2 dice? Yahtzee uses 5. That gets wicked. I actually decided maybe starting next year to teach Math 105 entirely with Yahtzee. Because I think I can do most of the topics in Math 105 using just Yahtzee. I'm almost positive of it. But no, Yahtzee uses 5. That gets really fun. My son is totally engrossed with that game right now. He's actually figured, he has an intuitive feel. I'm sure I've deceased him too, just by naming my kid. But he has an intuitive feel for what he should bet on and when, based on likelihoods. Not Yahtzee though. What is that? Baccarat? I don't know. What's Baccarat? Is it 2 dice? Then count it. I was thinking more of a traditional Vegas game.
Craps.
Craps! I was thinking craps, right? I mean, how many of you guys have played craps or want to play craps at some point in your life? Only one person, okay. 105, you all played it because I made you play with Starbursts. Yeah, that's right. Probably the most popular game in casinos. You know why it's so popular?
Pays off the most.
You lose your money the slowest. Ha! You lose your money. You have a quiz in a couple weeks that's based around the game of craps called the Gambler's Roll. It's a really fun, way of earning $1 in Vegas. So imagine, we'll come back to the other. So craps. So you would care about any game that uses a pair of dice, you might want to know about the distribution of Monopoly, I think uses a pair of dice. Board games, not necessarily gambling. So let's design the distribution for a pair of dice, if you roll a pair of dice. So what would X be in this case? What would you be interested in if you're playing craps or Monopoly or Baccarat, maybe? Or any other game that uses 2 dice, what would you be interested in when you roll the dice? What would you be interested in? Throw your dice right now.
Pair.
Throw your dice right now. What did you get?
7.
I got a 7, we got a 8, you got a 10, 9,
11.
11, 12, 7. What are you guys doing? You're adding the faces together, right? So the variable of interest for rolling a pair of dice usually is the sum of the pips, right? The sum of the dots. Does that make sense? That seems like a worthwhile thing to study, I think. Let's figure out what you got when you roll the dice, when you add them together. Now, there are all kinds of bastardized variants you can do with this. You can look at the difference between the high number and the low number. Gesundheit. The product on the dice. There's all kinds of things you can have fun with dice. But usually, when you play dice like craps, you just add up what you got on the face and look at the sum total. Fairly standard, yes? Okay, good. And then over here is going to be those probabilities, correct? Excellent. So first of all, let's make sure we're at peace with what these can be. So you throw a pair of dice, what can you get? 2 called? 2 is called snake eyes and craps, yes? 2, very good, very good. What else can you get? 3? Well, we'll just go in order, I think, to keep things kind of, you don't have to, but it makes the visual easier. 2, 3, tell me when to stop.
12.
Good, can't go any higher than 12, yes? Let's go with craps. Boxcars, there we go. Boxcars. All these have funny names. They all have funny names. 10, 7, 4. I forget most of them are. Boxcars and snake eyes and hands. Okay, so let's figure it out. Let's figure this out. What is the chance of rolling snake eyes? 1 out of 11. I love that vote. Who said that vote? I love it. 1 out of 11. I love it. Why 1 out of 11? Lydia, go.
Because there's 11.
There's 11 sums.
And you can only snake eyes past 2.
Here we go. I'm going to start clicking some data right now. We're going to test that. If you would, friends, Everybody roll their dice. Roll it once. Box card. 31. Okay, 31 people. I'm going to do a quick little calculation here while you guys are doing this. We got 31 people. I'm going to put it over here. How many of you got snake eyes? Who's got snake eyes? You got one? Okay, beautiful. One. All right, do it again. Some fun stuff. We got to call out 1 out of 30 now. All right, we got 30 rolls again. How many snake eyes? One. Beautiful. Roll again. So you're rolling now, right, my friend? Yep, awesome. We're capturing the mix too. Snake eyes. One. This is fun. People around the room too. I love that. Do it again. Snake eyes. One. Okay, so actually, let's just pause for a second. I want to do this a couple more times. This is freakishly fun. This is happening. Per 30 rolls, every single different person every time is getting snake eyes. How does this compare to rolling 6 dice and getting 1 of each? Is it more common or is it rarer? At least based on our data. It's more common. It's happening once every 30 versus ours, which is happening once every 120. So this should be higher than 1 in 120, right? But is it 1 in 11? Does it look like it's 1 in 11? It seems to be a little bit lower than that, doesn't it? Because there are 30 of us in the room. If it were 1 in 11, I would predict closer to 3 each time, wouldn't it be? 1 in 11 would be 3 in 33. I'm using fractions here, if that's okay with you guys. So if it was 1 in 11, it would be closer to 3 in 33. Throw them again. Throw them again. Throw them again. Throw them again. Snake eyes this time? Nobody did any that time. So I think 1 in 11 is too generous. I think, right? Based on, now I just made this based on empirical observation. In other words, you guys roll a bunch of dice and kept track of how many snake eyes you got. And we only saw, what, 4 in like 150. That seems too low to be 1 in 11. Does that make sense? Zach, get an idea?
Yeah, so like a 6 and 8, there's 3 combinations of ways to get
Oh,
6.
whoa, what is this combination stuff?
Like 1 and 5, 2 and 4, 3 and 5.
Okay, so Zach is already moving on to some of these down here. And he's saying there's more ways to get these numbers than there are to get these numbers.
But I think it adds to your 11 is not your max. So you
Okay, so maybe there's a problem with the 11. Maybe. Well, what should it be then? Janelle?
Okay, so the chance of getting a 1
Yes.
is like 1 in 6.
Is 1 in 6.
So if you have 2 dice and you have 1 in 6, so that's 1 in 36.
Check her out using your second project. 2 independent events, yes? Sampling with replacement. Reach into a hat with 6 balls, pull out a number and look at it. What's the chance it's a 1? 1 in 6. Put it back in, reach in, grab it again. What's the chance it's a 1? 1 in 6. What's the chance of both of those things happening? 1 in 6 times 1 in 6, 4, 1 in 36. Oh, I love that argument. I can't even argue that argument. Because number 1, the mathematics holds. And number 2, didn't we just see basically that happen? Didn't we just see about 1 in 36 happen? We got 4 in 150. That's pretty damn close to 1 in 36, isn't it, when you do the division? Do it again. Do it again. Snake eyes! We got 2! There we go! We're averaging out. There you go. I got no argument with that, Janelle. I got no argument with 1 in 36, do I? I can't. How can I argue that? I can't argue that. There's no way to argue it, because if you think about it, there are 6 sides on this die, and there are 6 sides on this die. That means there's 36 total outcomes altogether, aren't there? How many of them are snake eyes? Just 1. 1 in 36. Hot damn. Okay, what's the chance of a 3? That was a chance of 2, yes?
Same.
Same? Roll your dice. Roll your dice. How many of us got 3? How many of you got 3 that time? We got 1 3 over here. Roll them again. This is going to be subtle. It might be hard to detect. How many 3s we got? We got 3 3s that time. Roll them again. How many 3s we got that time? 1 over here. 3. Roll them again. How many 3s we got that time? subtle. Threes? It's subtle. We got 2 that time. Oh, it's subtle, isn't it? But did you see what just happened? Oh, so now Kelly's got to vote that maybe the probability of 3s is twice as big as the probability of 2s. You see how we were getting roughly 2 per trial that time? Or before we were getting roughly 1 per trial? Everybody catch that? That's what I was calling the numbers out. So when I had you guys measuring snake eyes, we were averaging about 1 per class. But with 3s, we were getting on average 2 per class. So it appears empirically that it's twice as likely. Prove it to me that it's twice as likely, mathematically now. I wouldn't do it Janelle's way, although it's slick. It's just going to be trickier. How many outcomes total are there on a pair of dice when you roll? We already established that, right? How many outcomes on a pair of dice when you throw it? 36. How many ways can you make a 3? 2 and 1.
2 different ways.
Two different ways?
Each dice could either be a 1 or a 2 on each of those combinations.
I don't believe you, Sean. Everybody make 3 on their dice. Make a sum of 3 on your dice right now. Everybody look at the sum of 3 on their dice? Now make a different 3. You can do it, can't you? You can do it, can't you? Right? If you had a red 1 and a yellow 2, you could then have a red 2 and a yellow 1. That's 2 different 3s, isn't it? Okay, now let's see why that can't be applied to snake eyes. Make snake eyes. Make a different snake eyes. Ha-ha! You can't. Because even though you can pick them up and go, oh look, you didn't turn the dice, did you? It's still the same 2 faces. So good. We should have twice as many 3s as 2s. Because it's a 2 in 36 chance. Very nice, my friends. Very nice, very nice, very nice, very nice. How about 4s? Just quick at this. We have a vote for 4 in 36. Or excuse me, for 4 should be 3 in 36. Everybody buy why it would be 3 in 36? Let's make sure we buy that. Make 4 on your dice. Make 4 on your dice. Do it again. Do it again. I should say do it differently and do it again. Right? Make it different 4. Can you make it a different way?
Yeah.
Do it again. Do it again. But you can't now, right? You've done it. So, describe to me the ways you can do it.
2 and 2.
2 and 2. Nah. 2 and 2. 1 and 3. 3 and 1. Why aren't you doubling the 2 and 2? Because you're not, very nice, Lenny, you're not changing anything. 2 and 2 is the same as snake eyes. It's just a different, it's like double snake eyes. Good. So it's 3 and 36 for sum of 4. Are you sensing a pattern? What's 5 going to be?
4.
Yes, absolutely. Let's verbalize it. 2 and 3, 3 and 2.
1 and 4.
1 and 4, 4 and 1. There's no doubles in there, so there's nothing to worry about that way. How about 6? You see the pattern? 5 and 36? Let's make sure we buy that. 3 and 3. 2, 4, 4, 2. 1, 5, 5, 1. So he's 5 there. 7? What did Carlos say?
4.
4? Well, let's count out.
No.
No!
5 and 2.
5 and 2.
5, 3 and 4, 4 and 3.
1 and 6, 6 and 1.
1 and 6, 6 and
1, 6, 6, and 1. Any number on a die can be used to make a 7, yes? It's one of those interesting sums. Any number on any one of those dice can be paired with another number on the other die to make a 7. That's kind of fun. Not every sum can do that. For example, if you roll a 6, you can't make snake eyes. If you roll a 1, you can't make boxcar. If you roll a 2, you can't make, I don't know, 10.
Is that why 7 is like a lucky number?
Yes, very much. Because look what, and it's also, I'll never forget this, about 20 years ago or so, when Who Wants to Be a Millionaire first was on the air. I don't know if it still is on the air or not. Regis Philbin hosted it back in the day. And the winning question for one category was, what is the, oh, let me pause the story for a second. Let's keep going. I'll come back to that. Sorry, I want to give an answer right if I tell you the story right now, but how about 8? Should be 7 and 36, right?
Flips. It's 5, 4, 5.
So, why does it flip?
Because we got to the, well, because we got to the number where you could use all of them, and so now, from now on you can't use all.
Good! Now you can't use, for example, if you roll a 1, On a die, you cannot make a sum of 8 anymore. Because there's no 7 on the other dice, right? The dice stop at 6. If you roll a 1 now, there's no way you can make an 8. So it's got to be less likely than a 7. So this is where you can actually just count it out, right? How many ways can you make an 8? Let's do it.
2 and 6.
2 and 6, 6 and 2, 4 and 4,
3 and 5.
3 and 5, 5 and 3. It's just as likely to roll an 8 as it is to roll a 6. They have the exact same probability because they have the exact same numbers of arrangements. Did you start it, Zach? This is great. It's beautiful. This whole combination thing is beautiful. What do you think about 9? If it follows the pattern, which it appears to be following, it should be 4 and 36. Yes? Should be. Let's figure it out. Make sure that's right. 6 and 3, 3 and 6. Jen, 4 and 5 and 4. See, again, you can't roll a 2 and get a 9. You can't roll a 1 and get a 9. We're starting to lose those small numbers now. Just like if you roll a big number, you can't get these small sums. Beautiful. 10. 11. 12. Box Carson. Does that make sense mathematically? Does that make sense what does this sum to? If you sum up that column, it's 1, isn't it? It's 36 out of 36, which is exactly what it should be. Because it has to account for every single outcome of the distribution. Beautiful. We now understand the mathematics of rolling a pair of dice. Now we can use them to answer Aaron's question, for example, why is 7 a lucky number? Well, there's a couple reasons for that. Number 1, it is the highest probability that makes it the mode. It makes it the most free. How many of you guys are rolling 7s? When I said roll your dice, how many of you are getting 7s? I would imagine everybody in here got a 7 at least once, yes? Maybe. I don't know how many times I had you roll. On average, you get a 7 every 6 rolls. Every 6 rolls of 2, yes? Good. Very good. Say that again?
I got 6.
And you got 6, you got 6, exactly. It's beautiful. On average, it will be 1 and 6. It's also it's not just the mode, it is the average. If you average that distribution, which we'll do when you guys get back from break, it's the average. What else is it? It's the median, because this is a very, very cool shaped distribution. It looks like it's bell-shaped, doesn't it? It's actually super bell-shaped. We'll come back to that. I've taken you over 5 minutes, I apologize. Go get some air, go get some water, let me fire up some technology, and we'll come back and we'll analyze this some more. You might want to preload by putting that into your TIs as well. We're going to want to look at that in your TIs too. Yes.